Hi there, welcome to your lesson on inflation, annuities, and amortization. This is some serious applied mathematics. Our course is really coming to life these days. Okay, let's begin with inflation. What is inflation? Inflation measures the rate that prices for goods increase over time, and as a result, how much less your money can buy. If prices go up, your money doesn't have the buying power it once did. An inflation adjustment is the change in the price of an article that is a direct result of inflation. Here's an example of inflation. We have then, sometime in the past, burgers. For $4.99 I could buy this much food, and now for $4.99 I can only buy this. That shows inflation. Prices have gone up, so you can't buy as much for your money. Here's another example. Price of coffee cups, cup of coffee over time. Look at the prices change over the decades. That shows inflation as well. Here's a map of the world showing countries and inflation rates. The deeper the red or darker the red, for example, Argentina or Venezuela or Turkey, those colors represent a very high inflation rate in 2019. Very high. Imagine 25% or 20%. Imagine prices all of a sudden from 1 month to the next, you were paying 20% more than before. That's a big thing. All right, let's do a quick problem. Inflation rate of a country was calculated to be 4.48% per annum per year. Given the same rate continues for the next 5 years, work out the percentage increase due to inflation at the end of 5 years. Think of this just simply like one of our exponential growth problems. The rate per year is 4.48%, and now apply that 5 times. Okay, so I hope you came up with something. 4.48% annually is like this, 4.48% over 5 years. That means we do 1.0448, right? Remember when we have a growth rate, we do 100% plus that, and then we have our multiplier for that period, right? So 1.04, this means 104% and 4.48, and that's applied 5 times 5 years. So that works out to this rate. That is our ratio for 5 years. Therefore, our growth rate is actually this 24.5%. So that's our inflation rate over 5 years. Now, second question. A computer game costs $35 today. How much would you expect for it to cost next year due to inflation adjustment? So this is not over 5 years. It's just 1 year to the next. So we're going to use this inflation rate. So you have your 35, you multiply by 100% and the 4% added, right? 1.0448, and you get the price, the new price of the game at the end of the year or next year. All right, that's a simple problem. Just shows you how inflation rates work. Okay, so now let's shift to annuities. What are annuities? Well, annuities are basically a way to save for the future, okay? There is an accumulation phase where you make payments to grow your annuity balance. So imagine you have an annuity set up at the bank, you make certain payments every month or every year, and that accumulates over time, and they give you interest on that. And then there's the payout phase, when money is periodically given back to you or paid back to you. So maybe it's set like for 20 years you put money into it, and after that they give you a certain amount every month or every year. So that's annuities. Accumulation, payout. We're going to focus on the accumulation phase first. So here's an example of accumulating an annuity. Abraham wants to save so he can retire early. He decides to save 5,000 US every year in an annuity that pays 4% interest compounded annually. So he'll put in 5,000 every year, and he'll gain 4% interest on that amount every year. But then at the end of the year, he'll put in another 5 and another 5. So it's going to keep growing, and his interest will keep growing as well. He wants to retire in 20 years. Let's see how much he has in 20 years. So here's how it begins. Year 1, he puts 5,000 in, and then he gains 4% interest. 4%, that means we're multiplying by 1.04, right? 104%, and we get the new amount right here. Okay, next year, he begins with that amount, adds 5,000 to it, so now it's 10,200. And then the interest is applied again. 1.04 gives us this. All right, so he ends with this amount. Next year, he begins with that amount and adds 5,000. Therefore, he has this amount. Multiply by 1.04 again. He gets this amount. Keep this going. Multiply it out. Do it in your notebook. And let's see. How much does he have in 10 years? Let's see what he has. Check your work here. Did you get this number? I hope so. Okay, now let's take a look. I don't want you to work this out, but let's take a look all the way to 20 then, because he's going to retire in 20 years. So here's the total in 20 years. Pretty good. Not bad, not bad. how is this different than if he had just simply taken 20 years times his 5,000? Well, 20 years times 5,000 is 100,000. So he has this much he got through this annuity minus the 100,000 he would have if he didn't invest it at all. He's up by 54,000. Pretty good, pretty good. Okay, there's a formula for annuities. So rather than having to do it row by row like that, we could have used a formula. Let me share the formula with you now. The formula is this. It says FV, which means future value, is determined by taking the amount you put in, the payments you put in, and then 1 plus the rate, the number of years, and then minus 1 over the rate again. So here would be the future value formula for this annuity, but I set it up just for the 10 years, not the 20. So here's the amount he puts in every year. Here's the 104%, right? The rate added to 1. 10 years, we're going to check 10 years, minus 1, and then over the rate right here. Okay, calculate that. What do you get? Well, I hope you didn't say this amount, because, well, maybe you're thinking it should be, because this formula should produce what we see here, but it doesn't. So why not? Let me talk to you about that. Why are these numbers different? Because this annuity formula should show us what we were getting in this annuity. So let's see where the difference comes from. It comes from this. Banks are not that generous. They will not take your 5,000 that first year and give you interest. Why? Because maybe that 5,000 was put in, on the third day of the year or halfway through the year or who knows when. They will not give you interest unless they have had your money for a whole year. So the assumption in annuity is that that payment was not necessarily made on day 1 of the year. So they won't give you interest. So this is how it begins. You begin with 0, and they give you interest on whatever your account began with. So we say it began with 0, so they give you interest on that, which means you get nothing. And then at some time in the year, we can say, assuming it's closer to the end of the year, you add your 5,000. Okay, so they won't give you interest on that. Next year, you begin with that 5,000, then they give you 4% because that 5,000 has now sat in there for a year. Okay, because this 5,000 came in at the end of year 1, so now that 5,000 by the end of year 2, it's been in there all year. They give you the interest, and then you add your next 5,000 at the very end. Let's say the last day of the year, they say it's like that's when you add your 5,000, and then that continues. So basically, you didn't get interest for the first year. That's what happened, and everything goes up, 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 and there it is. There's the 60,000 that we see matches our annuity. So that's something important to know. The annuity formula assumes that you make your adjustment, the amount you put in happens near the end of the year, and then the next year begins with that amount. Okay, important to know. So annuity formula, there it is again. We're going to look at it written out in a different way. Let's say you had 5,000. Okay, so end of year 1, you put 5,000 in. Okay, end of year 2, you get 5,000 times 1.04. That was your original 5,000. So they give you at the end of year 2 that 5,000 has been in for a full year now. So they give you interest on that, and then you add your extra 5,000. Okay, then end of year 3. There's this full amount now that's been in there for another year, year 3. So they take that full amount and give you another interest on that, and then you add your extra 5,000, right? There's always that extra 5,000 you add at the end of the year. So 1.04 times all of that. Okay, so that's over 3 years. That, if you see, this 1.04 can multiply here and here. And when you multiply that here, you get 5,000 times 1.04 squared. And then that times this, 5,000 times 1.04. And then you have your extra 5,000. Now look at this carefully. What do you see? I see a geometric sequence. For sure, this is a geometric sequence. It's written kind of backwards, but we can say 5,000 is like our first term, and then 5,000 times 1.04, and then 5,000 times this, dot, dot, dot. We can see a geometric sequence. So our value of the money in our account is actually a geometric sequence. And we see that R value is 1.04 because it goes up by that multiplier every time. All right, now, since it's a geometric sequence, we can use the geometric sequence formula to find the sum. So if you can find the sum of all those pieces, you have your total value at the end. The sum of all those is your value. So here's a geometric sequence formula. I'm going to put in 5,000. There's our U1 right here. There's our rate to the third power if I'm doing 3 years. Minus 1, 1.4 minus 1. And we're going to get some amount after 3 years. Okay. Now, comparing to the annuity formula, look, 5,000 plugged in, 1.04 here. Here's 3 years. Look at that. Do these look similar? They definitely do. Look, 5,000 is here, 1.04 to third power is here, minus 1, and then 1.04 minus 1 is that. So guess what? The annuity formula is not some mysterious thing. It comes from the fact that our annuity is a geometric sequence, and we have the sequence sum here, which turns into the annuity formula. Very good to see these connections. Our geometric series come back in many ways. Comes together. Here's a problem where somebody is trying to save a bunch of money. At the end of 10 years, their goal is to have 1 million Turkish lira, and they put it in an annuity with 4% interest. Let's see how much they have to save every year. In other words, what is that amount they have to pay every year? So let's check. Here's our annuity formula. We put in the million, that is the goal. We put in the rate of 1.04, and the A is the unknown part. And here's 10 years. Here's the unknown thing. We want to know how much they need to pay every year. This would be a tough thing to graph and find the solution. So good thing is we can use our calculator to do this. There's an app on our calculator called the Finance app, which is going to help us. Let me show you how to use it. Press on, and then go to apps, and then I have Finance here. Find it on yours. There. TVM solver is what you need to use. Enter. Okay. N is the number of payments. So 10. In this case, we're going to put in 10. Okay, what else? Show you here. So 10 was the number of years. 4%. The second one's interest, so you put 4. Don't put a decimal. Present value, we don't know. We're not using that here. Payments, that's the amount you're going to be paying here. We don't know. We leave that blank. That's what we're going to figure out. Future value is the 1 million, so you put it here. Here's payments per year and compounds per year. That you leave as 1. So anyway, you fill it in like that, and then we're going to find out the payment. The way to do that, the way to calculate that is cursor to the payment, the thing you're looking for. You press alpha and then enter, which is solve, and it solves it for you right there. There's the answer. It tells you is this person needs to put this much in every year in order to make 1 million in 10 years under this annuity. Okay, let's go next one. So let's talk about annuities. We've talked about accumulation phase. Now we're going to look at the payout phase. Okay, so number 1, let's say we have this problem. Somebody has an annuity of this much, and then in 5 years they will gain for 8% per annum to be paid out monthly. So they're left some money, and they're going to be paid out some amount. They're not going to get all of it at once. They're going to be paid out in annuity, so in a little bit at a time with an 8% interest rate. So the bank will give them extra money. So let's find out how much they get. So on your calculator this time, in the app, you'll put in 60. Why 60? Because they're going to be paid for 5 years, but they'll be paid every month. They're going to get a monthly payment. So 12 times 5 is 60 payments they'll get. 12 payments a year times 5 years. The rate they're going to get is an annual interest rate of 8%, but that means 8 divided by 12, because again, they're being paid every month. So you take the 8% divided by 12, you type it in like that. The present value is 5,000. So right now it's worth 5,000. And we're going to figure out how much payments they get. Okay, everything else stays as it is. Let's put in enter. So again, you go up to payment. Everything like this, you put a future value of 0 because it will be fully paid out, and then you go to payment, hit alpha, solve, and you get this answer here. That's how much they will get every month for 5 years. Let's talk about amortization. What is it? Please pause for a moment and read this. Okay, now that you've read it, you understand we have a loan of 1,000, we're paying it off, the bank is collecting 1% interest. So, first of all, they say you owe us 1,000. They apply the 1%, they say we're going to take $10 interest. So you make a payment of 200, but only 190 of that goes to pay off the 1,000, and the other 10 is just interest. The bank just takes it. All right, then you do 1,000 minus the 190. Now you owe them this much. So they apply interest to that. Now the interest to that is 8.1. So that means even if you pay 200, you're only paying this much off of the total. And on and on and on it goes like that. So basically what this shows is over time, the interest becomes smaller and the amount you pay to the principal becomes bigger. So that's good. That's how amortization works. So here's a problem like that. This person takes out a car loan, this much. They need to pay it off in 10 years at 1% interest every month. Let's see how we do it. So enter these values on your app. 120. Why is it 120? Because it's 10 years and they pay every month, so 120. 1% interest, present value, you need the future value to be 0. You want to pay it off. Okay, enter that exactly like that. Go to payment, hit alpha, solve, and check your work. Those are the payments you have to make every month for 10 years to pay off this car loan.